Thanks, Josh. It's great to be here, and it's exciting to follow what is literally 12 brilliant presentations. So with that, I'm going to try to cap this presentation off with some really interesting things that we're doing at Streamit. You know, we were founded initially to try to understand how do you put compute stacks on mobile public transit buses and achieve video analytics for safety, security, et cetera. And on this next slide, we can demonstrate some of the traction that we've ultimately achieved by starting with those kind of modest beginnings. Our goal was to try to understand how do we build really good hardware that can see and use machine vision to extract good video analytics. And so in the process of doing that, and over the last 3 or 4 years, we've gained some really good traction, both in smart city activity, as well as even in home building. We've got some pretty good visions concerning homes and how smart homes need to be extremely smart. In addition to that, we kind of stumbled on during the COVID downtime, the concept of a micro home on an energy platform, such as the Tesla Cybertruck. And so we have this other product line called Cyberlander, and we can talk more about that in the Q&A. But suffice it to say that we've discovered really good traction in highway analytics, safety and security, monitoring humans in areas that require deep introspection into what their actual activities are about, either nefarious or good. And lastly, we've really learned a great deal during the COVID period about analyzing hand washing of all things. So as a company, we've really focused on a number of different avenues to use an AI technology in order to improve analytics and data about that. On the next slide, there's one thing that we've back up one. There you go. One thing that we've understood about everything that we've done thus far is that all of our projects with IoT and AI and machine vision typically come with this challenge of one-offs. All of us are kind of in that boat, and we're trying to understand how do we do this better. And so on the next slide, in public transit, we looked at the complexities of typical hardware stacks that we see in order to guard safety or record video, or to even do simple things like passenger counting. And we said there's a big problem here. We have to compress that. And the way to compress that is to take out all of the redundant power supplies. Many of the communications things are redundant, and compress all of that information and technology into a very small box. Typically a box that can have multiple camera feeds as well, because central to everything we do is about vision and analytics. And on the next slide, we discovered that now that we have really good handle on the vision and the ability to gather data, how do you move the data? How do you organize the data? So we realized that there was something missing from real-time video analytics, and that was real-time data analytics that really served in a more elegant manner to support each of those processes. And so we built the Streamit real-time analytics platform to go along with our hardware. On the next slide, we then combine those two to create what we largely regard to at Streamit as this comprehensive vision that attempts to compress, unify, and operationalize AI. And it really requires a much larger discussion, because at the end of the day, one of the things that are critical about building AI products is the ability to perform repeatability, but to also be able to deploy them very quickly. And so those two layers, the hardware and the software layer, is where Streamit has created some very distinct competitive advantages. And we've applied this to a number of customers. On the next slide, you can see where we've taken this architecture and we've spread it across the valley to understand how are vehicles moving about that valley on the highway systems. And this basic approach then leads us to understand, well, what are the problems and the issues that we're going to run into trying to do this at scale, because scale is so important. And highway analytics really is the tip of the iceberg. We see our platform as being quite pervasive and quite beneficial in facilities, logistics, any place that things are moving about, whether it's machines, people, equipment, or vehicles. And on the next slide, you can actually see all of that information rolling up into what we call our Streamit Cloud product. So we've designed an environment that is agnostic to the entire perspective of trying to assimilate machine vision and AI outcomes in a way that anybody can use it. So we try to make them, a very easy veneer to use, and also one that's configurable. So it may not be a large screen that somebody needs to use our technology with. They may need a mobile app. And so we spent a lot of time investing. And by the way, we're self-funded. We are seeking strategic partnerships to broaden some of the ways that we use these technologies. On the next slide, you can see that our advantages at a very low level include, of course, rapid install. In many cases, we've seen the ability to use our platform and install it within days instead of weeks or months or even years. We have very simple configuration environments in there. It's sustainable, easily trainable, and we even invest a fair amount of time in the concept of software and hardware that is self-healing and self-cleaning. And so when you even say the word self-healing, you have to think about software that is smart enough, to be better software than it might encounter issues and things like that. Products that are self-cleaning means we put a lot of time and energy into choosing materials. So we're really good on the materials and the design and manufacturing side, and we're equally good on the AI side in applying these technologies. On the next slide, we can sum it up pretty simple. As a self-funded organization, and we're also funded through many of our revenues, we're really looking for strategic partners. We know that there's a ton of challenging use cases out there where our platform would apply our competence in AI and our competence in hardware design and solution design. We think that brings us to a new level of where data science is going. And so we're trying to make this affordable luxury known as really crafty, clever data science emerge from these two layers that we've managed to put together: real-time data and, of course, real-time video analytics. Now, one of the things that separates us in a competitive sense from everybody else that seems to be working in this space, a lot of companies will focus very carefully on performing AI at the edge. We do that, of course, and AI in the cloud long after the data goes to rest. We took another layer of that and we said, look, you really need to be able to perform AI at the edge, in the stream, as the data is moving, as well as at the cloud. And we believe we're the only company that really thinks about those three layers with equal deference. In addition to that, on the next slide, we'll demonstrate we got a team. We've been working together for about 4 years. We have lots of depth in different technologies, from mechanical to electrical engineering, as well as AI and modeling. And with that, I'll throw it out to anyone who might have some questions.
Thank you, Bill. Opening up the floor. I think Bob has the first question.
Yeah, thanks for the presentation. Question, have you deployed your video monitoring system in any kind of petroleum or chemical factory? The reason why I ask that is because there's specific requirements of anti-explosion. Any IoT device that goes on the factory has to be anti-explosive. So I'm just wondering if you had to incorporate that into your system.
No, we haven't had the opportunity to do that, but that is an important one. In fact, I wrote about that in I think a watershed paper that I wrote back in 2016, where I recognized that the concept of IoT was flawed. And it's flawed because IoT, it may be able to tell you how hot a fire is, but it can't tell you what color the flames are. And flame color is like another data element. And so in a petroleum environment, I think the ability for vision sensors to be acutely aware of that which they're trying to detect tends to allow us to compress the concept of IoT into a vision sensor, really literally making the vision sensor a proxy for 10, 20, hundreds, maybe thousands of IoT sensors that it could replace. I believe that IoT is a subset of the Internet of Recognition, which is what I wrote about in 2016.
So do you have plans to just incorporate that to meet the needs of the chemical factories? I'm just wondering, is because this is an area that we've looked at before in our company, and we haven't been able to deploy anything because of this requirement. So I'm just didn't know.
Right.
That.
It's a tough problem, right? Because IoT sensors, first off, much of the infrastructure cannot participate in the IoT, right? Not without retrofit, not without additional infrastructure changes. Whereas vision, machine vision, has the ability to participate with a 40-year-old valve. It can tell if that valve has been turned. It can even tell who turned it. It can tell what level of rate of flow that valve has simply by gauging, the nature of the valve. And so the answer is very brief. We have not had the opportunity to do it. We would love the opportunity to do it. And second to that question is, fundamentally, all of this is based on sensor technology. A vision sensor is no different than an IoT sensor. It's just has the capacity to capture light particles. And if you capture the light particles right, and you use the right sensors, the data possibilities in machine vision are way off the chart compared to where IoT sensors are able to go.
Just one last question as it came to my mind. Sorry about that, but I was just thinking about if you had the ability to do a three-dimensional camera, and you could create digital twins. There's a lot of discussion in factories and about creating digital twins. BASF did it with their factory in Germany.
Right.
It's becoming more. It's becoming a big area, and I'm just wondering if you're able to, or anticipating that, and how you would support those efforts.
Yes, we are anticipating it. We have thought about it a lot. Haven't had the opportunity to do it, but we are Inception partners with NVIDIA. We work closely with NVIDIA technology. And so thinking about digital twins, thinking about 3D imagery, it's all at top of mind for our engineers. And we are doing it, by the way, in our own factory at Cyberlander. Cyberlander, for lack of a better term, is a camper designed for a truck that doesn't exist yet, but will soon exist from Tesla. And that camper is designed to be invisible when you don't need it. And that particular product, we've sold almost 100 million in advanced reservations for that product. And in our factory in Austin, we will be using exactly the concept of digital twin technology. So yeah, sensors are very important to us. In fact, we also have separately, which kind of pertains to our home development, both micro home as well as our EcoMansion brand, sensors that have the capacity, that are patent pending, and have the capacity to do things that are at a much deeper privacy level, much deeper security level. And those are patents that we've been working on concerning sensors. So yeah, we've got some brainiacs here that are just constantly looking at how do you make a vision sensor even more capable as a data gathering tool.
Mm-hmm. Yep, great. We'll talk offline, but I'd like to learn some more.
Sounds good. Thanks.
All right. Hey, Saul Cates here. One question for you. You just sort of hinted on it at the end of that stream of consciousness.
Yep.
Data privacy and usage in sensitive locations. Hand washing in a bathroom, setting might be very sensitive, as you can imagine.
Yes.
But also the privacy of citizens and others that might be coming in and out of an environment that this would use. Can you talk a little bit about what you guys are doing or anticipate doing there?
Yeah, definitely. I mean, what you're hitting on is the idea that you need a camera that can't see, right? I mean, fundamentally, you don't want it to see everything. You want it to come to the table with a level of privacy. And so Lance King, our founder, has actually worked on this and has, nudged this along into the patent stage because camera sensors, well, we all know that security and privacy are utmost in our society. You cannot, debate that. But then when you get into a bathroom setting, it goes off the chart, right? You cannot expose anything, but you still want the analytics. So you still want the ability to see some sort of an operation that a human may be conducting. You can do that in a number of different ways. Most organizations try to use masking and things like that. Masking is not the right way to do it, though. You literally need to take a different approach, and that's one of the things that Streamit has done. Now, in our we call it the Healthy Hand brand. That's our internal term for it. But during the COVID downtime, we kind of focused on this as a potential for using camera sensors. And I say camera with that's a very loose term, because we're really simply trying to assess, did they follow the 10 CDC guidelines to get through that hand wash? And did they do it at least 20 seconds overall, or 5 seconds per segment? And we've had no trouble creating AI models to do that. And I don't think any company would, really struggle at that. I don't believe that's a competitive advantage. What is a competitive advantage is to be able to deploy 10,000 hand wash stations and know in an instant who are the leaderboard people on that hand wash thing. Because in a healthcare facility, you might want to gamify that constant movement of hands over water to try to mitigate disease. Does that answer your question?
It did, thank you.